Hello everyone. In today's session, we are going to discuss a basic concepts in thermodynamics. What is thermodynamics? Thermo means heat and dynamics means power or motion under the action of force. So thermodynamics in physics, it is a branch of science that deals with heat, work, temperature and their relation to energy, radiation and physical properties of matter. So let us discuss what is system, surroundings and boundary. A quantity of matter or a region in space which is chosen for a study is called as system. The mass or region outside the system are called as surrounding. The real or imaginary surface that separates the system from the surrounding is called as boundary. So in the diagram we can see that here a beaker is filled with a liquid where the liquid considered as a system and beaker can be considered as a boundary and everything outside the beaker is a surrounding. So the system and surroundings together called as universe. Now let us see what is thermodynamic properties. It is a measurable characteristics of a physical system that define its state. They describe how a system behaves under specific conditions, and these thermodynamic properties are classified into three types: measured property, fundamental property and derived property. Now what is measured property? The properties of the system directly accessible in the laboratory are known as measured properties. We can take the examples of volume, temperature and pressure. The properties of the system directly related to the fundamental laws of thermodynamics are known as fundamental property. Examples: internal energy and entropy. The properties of the system that have specific relations and which includes combination of both measured and fundamental property are known as derived properties. Examples are enthalpy, Gibbs free energy. So the fundamental properties and derived properties cannot be measurable. Let us discuss the two more properties under thermodynamic system. They are extensive property and intensive property. Now what is extensive property? An extensive property's values depends on the quantity or size of matter in the system. In contrast, extensive variables help characterize the specific system being analyzed. For extensive property, we can take the example of mass, volume, internal energy, enthalpy, heat capacity, entropy, Gibbs free energy. Now when it comes to intensive property, those properties that do not depend on the quantity or size of matter are known as intensive properties. So intensive properties may vary from place to place within the system at any moment. Examples are density, pressure, temperature, specific volume, etc. Now what is thermodynamic system? Thermodynamic system is a region of space that contains matter and energy and is defined for thermodynamic analysis. It can exchange matter and energy with its surroundings. Now these thermodynamic systems are classified into three types: open system, closed system and isolated system. Let us discuss one by one what is open system, what is closed system and what is isolated system. A system which exchanges both matter and energy with its surrounding is called as open system. In general, we can take an example of an open cup of tea, which will be considered as an open system because it will exchange both matter and energy with its surrounding. What is closed system? A system which exchanges energy with its surrounding but not a matter. Example, a tightly capped cup of tea. Here only energy will be exchanged but not its mass or matter. The third one is isolated system, a system which can neither exchange energy nor matter with the surrounding. We can consider an example of tea in a closed, well-insulated thermos bottle. So these are the three systems comes under thermodynamic system. Now let us discuss what is state, equilibrium and process. State is the condition of a system which is defined by the values of all its properties. So state gives a complete description of the system. In a graph, we can see that the state 1 and state 2, which represents in a path, state 1 is the initial condition and state 2 is the final condition. For state, when it comes about its properties, we can take it as P1, V1, T1, which means the pressure, volume, temperature in the initial state, and for the state 2, P2, V2, T2, which is a pressure, volume, temperature for the final state. Now what is process? Any change that a system undergoes from one equilibrium state to another is called as a process. So in the diagram, a curve represents a process path which changes its state from one equilibrium state to another, that is called as process. Now what is thermodynamic equilibrium? For attaining state of thermodynamic equilibrium, the following three types of equilibrium must be achieved. The first one is thermal equilibrium. It means the temperature of the system does not change with time and has same value at all points of the system. So thermal equilibrium means temperature should remain constant. Next one is a mechanical equilibrium. It means there are no unbalanced forces within the system or between the surroundings. So in this case, the pressure in the system is same at all points and does not change with respect to time. It means a pressure remains constant, so that we can consider it as a mechanical equilibrium. The third one is chemical equilibrium. As the name indicates, no chemical reaction takes place in the system and the chemical composition, which will remain same throughout the system and does not vary with the time, is called as chemical equilibrium. Now let us discuss a laws of perfect gases. The gas laws are a group of laws that governs the behavior of gases by providing relationship between volume, pressure and temperature. Now let us discuss one by one. The first law is Boyle's law. The first established by Robert Boyle, and this law states that the pressure of a given mass of gas is inversely proportional to its volume at constant temperature. And mathematically we can represent it as P is directly proportional to 1 by V or PV is equal to K. Here P stands for pressure of the gas, V is the volume of the gas, K is the constant. So Boyle's law can be used to determine the current pressure or the volume of gas and also can be represented as P1 V1 is equal to P2 V2. Next comes a Charles law. According to this law, it states that the volume of a gas is directly proportional to its absolute temperature at constant pressure. It can be mathematically represented as V proportional to T, or we can also written it as V1 by T1 is equal to V2 by T2. The Gay-Lussac's law, it states that at constant volume, the pressure of the gas is directly proportional to the temperature of given gas. That is, P by T is equal to constant. According to Avogadro law, it states that a same number of molecules exist in the system. The law also states that equal volume of gases at the same temperature and pressure contains equal number of molecules. It is given as V by N is equal to constant, where V is the volume and N represents the number of gas molecule. The combined gas law, it states that by obtaining or by combining three gas laws which include Charles, Boyle's and Gay-Lussac's law, the law shows the relationship between temperature, volume and pressure. We can written as PV by T equals to K. And the last one is ideal gas law, which is also known as a perfect gas. It establishes a relationship among the four different variables: pressure, volume, temperature and amount of gas, that is N. We have the relation PV is equal to nRT, and we can also use the equivalent equation as PV is equal to KNT, where K is nothing but a Boltzmann constant and N is number of gas molecules. Thank you.